companies that have spoken have I think, given you an idea of the breadth of the type of work that happens here in aerospace in California, but also the level of complexity that is involved in developing aerospace platforms. And our final speaker, Eric Mehiel from Cal Poly San Luis Obispo, has a lot of experience in this systems engineering aspect of how you take all of this varied approach to the avionics, the propulsion, the communications, the computers, and integrate it into vehicles. And it's amazing, with the CubeSats that Richard mentioned, that students, especially here in California, are getting these opportunities in the small sat environment. It gives them a really good hands-on experience for how to do some of the systems engineering, helps educate them as they go out into our complex industry. So Eric is going to speak a little bit about some of this from an academic viewpoint and a research viewpoint, and a little bit about, I guess, what students are doing as well, I hope, because I'd love to hear about what students are doing. Eric is an associate professor and chair of the Aerospace Engineering Department at California Polytechnic State University, San Luis Obispo. He's engaged in research developing the tools required to design and analyze these complex systems I was just talking about. He's working with graduate and undergraduate students and with industry and trying to address their needs. They're working on different model-based systems tools, and I'm not going to go into all the great detail, but modeling, simulating, analyzing, and figuring out these complex systems and how to operate them. He has some experience in industry before going to Cal Poly. He was at the Boeing company, appropriately enough, as a systems engineer. So Eric, please.
All right, thank you. Yeah, I don't have a video, but thanks for having me. So it's a thanks to the AIAA and thanks for the state legislature for having us up here. And I think this is a really good opportunity for the aerospace industry. Obviously, in California, it's a big industry. And I want to talk a little bit about Cal Poly in particular, because I like to brag on Cal Poly. I think just about every speaker here either had a person up there or mentioned something that actually is Cal Poly related. There's Burt Rutan as an alum from Cal Poly, and so on. So I could go on and on, so I won't. But I also just want to talk about academia in general and some of the issues that we face in California. And so the one thing that I get asked a lot, especially by freshmen, is that what is aerospace engineering? So I wasn't quite sure what the crowd was going to be, so I figured I'd make it really simple. And I know that I could have picked any airplane there, and somebody would have been mad. So I just went with the JSF. But so within the world of aerospace engineering, we break it down from an academic point of view to aeronautical engineering and astronautical engineering. And that's part of how we accredit institutions, as far as a bachelor's degree that's accredited in aerospace engineering. We at Cal Poly have two very deep concentrations in aeronautics and astronautics. So aeronautics is stability and control. So that's the pilot or the not pilot. We have structures. So how are these wings going to stay together? Aerodynamics. So you look at the flows over all these different systems. And materials. You talk about the different materials that are used to build these planes, from composites to high temperature materials. And propulsion systems. So that's a big part of what we do. And then also flight mechanics. How do these things actually move around through the air? So those are the topics that we have to cover within our degree program. So as a student, if I were to, this is the student level perspective. If you're a freshman, you say, this is what you're going to do for the next 4 years. On the astronautical side, or the astronautical engineering side, this is the recent SMAP mission that was launched just a couple months ago. We have to focus on a slightly different set of topics, and those topics are the space environment, and we're actually one of the only undergraduate institutions in the country, so far as we can tell, that has a space environment lab at the undergraduate level. So our students learn about the challenges of designing systems that are going to live in space in a very harsh environment. They have to learn about telecommunication systems, so that's a big part of getting data back and forth. That's the whole reason you're sending that spacecraft up there, typically, is there's some data involved. Rocket propulsion. So obviously, with SpaceX and the other launch providers that are here, talking about the launch vehicles themselves, but also then the spacecraft has to be able to maneuver in space. So there's a totally different size of thruster systems that are involved with that. Attitude, dynamics, and control, and that's actually my area. as well as the systems engineering. But how does a spacecraft, it's not about how it feels or if it's got an attitude. It's where is it pointing, okay? And so again, not knowing the crowd, maybe you know all this. And then structures. This antenna for the SMAP mission is, again, it's about the size of a tennis court. So you have these really big, flexible structures that are wobbling around that have to take very intense, very high precision scientific data or are involved in some other mission. And then, of course, orbital mechanics. So how are you getting around Earth or out into interplanetary trajectories or what have you. So those are the topics that we have to cover within the astronautics side. And this is something that we just recently did. Starting in 2013, we have a renewed astronautics concentration where we cover all these areas. And I'm proud to say we just went through our accreditation review, and our reviewer was very impressed that he felt that we're one of the only institutions in the country that actually does this to the level of that covers these topics, with the exception of the Air Force Academy and the Naval Academy. So we like to say that we're in a pretty good group there. So the other thing I wanted to talk about, and I'll kind of get to this to the end, is that as a educational institution and higher ed, we're that link, right, that goes from K through 12 into the workforce. So I wanted to talk about workforce a little bit. This is from Aviation Week workforce study from last year, and it's just a sample of the hiring that's planned for this year within the industry. And this doesn't represent total hiring, it's just a sample. But what you can see is that aerospace is one of the bigger disciplines that they're hiring in there. But in fact, they're hiring all sorts of different kinds of engineers. And I have some charts that I present every once in a while that talk about, what is aerospace, what do we do? Some of the really cool things that we've done. Civil, it's hard for me to find where the civil engineers fit into the aerospace industry, but then I found out that the aerospace industry is credited with inventing microgrooving, which is not a form of dance, but is actually cutting the slots in the road, all right, so that in the concrete road, so when it rains, the water just goes into those slots, and you get a nice surface for a lot of traction, and they use that in airports. So I'm assuming it was a civil engineer that invented that. I don't know. But it's a very diverse industry as far as just from an engineering perspective. Okay, so our students, although they have to learn all those other topics that I just talked about, they also have to learn how to interface with all these other kinds of engineers. Software engineers tend to be the biggest challenge from our point of view in terms of getting somebody that's very interested in a tangible structural thing to talk to somebody that's writing code. That's an interesting challenge. So where are the jobs? You guys may have seen some of this or know this. I just wanted to highlight it. This is from the Bureau of Labor Statistics. California is that high end. It's that 15,400, and that's just aerospace engineers. It doesn't include every other type of engineer or other person working in the aerospace industry. The next is let's actually have it here. Make sure I get the right numbers. Washington has 8,120, and then Texas, Ohio, and Florida is at 3,000. So we're far and away have the most engineers and people working in the industry in California. The mean wage of an aerospace engineer working in the state of California is $111,000 a year. So we have good paying jobs, although it's an expensive state to live in, but good paying jobs. What else is interesting, if you then overlay the number of universities in those states that have aerospace engineering programs, this is what you get. And this data comes from ABET, which is our engineering accreditation agency. And you can see that California has double anybody else in terms of programs within the aerospace, that call themselves aerospace engineering bachelor's degree granting programs. So this doesn't include graduate programs. 5 of those are in the CSU system, the California State University system. 4 of those are in the University of California system, and 1 is private, and USC, so everybody can name that one. So there's, and I think as everybody pointed out, these institutions that offer aerospace engineering programs are typically near centers of industry, with the exception of Cal Poly. We're out in the middle of nowhere. What we do within academia, Fundamental research is obviously a big part of what we do with graduate programs and graduate research. But also applied research. Our industry is pretty unique in that a lot of what we're going to do is going to be applied in a very short order. And so there's a lot of opportunity to try to take technology that's being developed in the lab and then go actually fly it pretty quickly. And then obviously educating our students. That's our primary mission. Okay? And at Cal Poly, we're predominantly focused on the undergraduate part of that mission, educating undergraduates. So, wrong way. So now I want to say, just talk about Cal Poly a little bit. I try to be a little general, talk about Cal Poly in particular. I think that we have a unique approach to education, and we call it our learn by doing philosophy. But basically the idea is to train the students on how to actually be an engineer as opposed to the theory that you need to understand to get an engineering degree. So we constantly get feedback from our industry partners that our graduates know how to do their job when they graduate, when they're first hired, and that is our mission. That is what we're after. It all began in 1927. The department was founded, and in 1928, that's a picture of students and then two of the faculty standing up in the back there, and that was the first plane that we built at Cal Poly in 1928. It was based on Lindbergh's design, the Spirit of St. Louis. This logo here was on the side of the second plane we built in 1931, referred to as Miss Polytechnic, but also referred to as CP2 or Cal Poly 2. And that was in 1931. Then in 2007, we launched the first CubeSat, and that was put into orbit, and that was named, not really knowing the history on this, CP4. All right, so if you talk to Jordy, who developed the standard for CubeSat, he didn't know that we had Miss Polytechnic back in 1931. So it's kind of a nice accident. The consistent theme here, though, is that there's an airplane built in 1928 by students and faculty working together. And by the way, those faculty their expertise was actually in automotive technology. But they said, yeah, let's build a plane. Seems like a good idea. So they did. I think that's one thing that separates Cal Poly 2 is that we're not afraid to try anything. It seems like a good idea. Let's build a small satellite. So these CubeSats, if you're not familiar with CubeSat technology, 10 centimeters on a side, 1 kilogram mass that are designed, built, integrated, tested, and integrated on the launch vehicle by students and then operated by students. So we currently have 4 satellites in orbit that we're operating from our ground station on campus. And so this is part of how the students actually learn to be an engineer is because we make them be an engineer while they're actually getting their degree. This is the SMAP launch that happened the end of January. There were a number of CubeSats on that launch vehicle that we're talking about as far as how we have to hitch a ride into space, and that's the way to make it affordable. One of the satellites on there, though, was ExoCube, which is now is operational, and it's taking data about the exosphere. So it's trying to understand the composition of the upper atmosphere, which really hasn't been tested since the early days of the space program. So it's gone from kind of a novelty. The first thing that everybody did was take a bunch of pictures. So that's a selfie that we happened to get. It was a total accident. These things pop out of basically a jack-in-the-box. It's called a P-pod, if you're not familiar. And the satellite behind our satellite was built by the Aerospace Corporation, and its goal was just to literally popped out. It had cameras on all sides, and it took a bunch of pictures, and then it ran out of power. So happened to get CP4 there with Earth in the background, and so we'd like to show that picture off as much as we can. But again, you see the SMAP launch on Delta down at Vandenberg Air Force Base, so very local, Central Coast. There was a wine and cheese party. No, I'm kidding. Central Coast, okay. So this was actually 6 in the morning, so we're all standing around. And in the center there is our dean, Dean Larson. She's been great. And then faculty, the guy with the beard in there, he's actually a computer science faculty who works extensively with the students. And then almost everybody around there. There's a couple of alum that are working at, I think some were actually SpaceX employees. There's a couple and then some students that are working on that project there, on the ExoCube project. So we're still dedicated to CubeSats. We see that as one of the primary ways that we can achieve our mission of educating our students. The other thing that we're working on is we have a long history in building aircraft, and we know that the aircraft, there's a lot happening within the aircraft industry, and there's a lot of innovation going on, and we're very excited about what's going to happen with the UAV market. And so then we're trying to find, well, what's the Cal Poly flavor of that? And we really think that what's the application of these flight systems, of the autonomous flight systems? So we're really looking at developing a capability to do some engineering, design, and test to see, because everybody, yes, I bet everybody here has a business idea of how to use a UAV. And it's all different, and some of them are probably pretty good, some maybe not. And so part of what we want to do is develop the capability to do some engineering analysis and to partner with industry folks from an innovation point of view to try to say, well, what's the next thing going to be within the UAV market, and get our students trained in how to work in that industry, in that market, and then maybe go out and start companies or work for the large prime contractors or whatever it happens to be. So we have an RMAX helicopter that was donated by Northrop Grumman. We have, we're talking with Boeing, looking at a Raven. We work with AeroVironment extensively, General Atomics. So we work with all these industry partners to help develop capability and to help inform us, and what's the important thing that we should be looking at as we look 10, 15 years out. I kid you not that we were talking with the viticulture program. So we see that there's a good, for Cal Poly in particular, there's a good opportunity to mix aerospace with agriculture, because we're also a big agriculture school. And one of the primary markets for UAVs is going to be agriculture. I don't know exactly what that's going to look like. But we were talking with folks in the viticulture department, and so apparently you can tell when grapes are ripe by sensing the amount of ethylene that's in the air around the grapes. So if you fly an ethylene sensor up and down your vineyards, then you can get a very clear map of when the grapes are ready to be harvested, and then you can basically plan your harvest better and increase the quality of your grape, or make it cheaper, whatever your goal happens to be. So those are some of the ideas that we're floating around that we really see some opportunities here. Search and rescue, firefighting, these are obviously some other opportunities. So we're looking at all these different opportunities. So again, we see ourselves as a link between K-12 and industry. All right? So our goal is to prepare the students coming out of high schools, and with it being a CSU, that's predominantly the California high schools, and to get those students ready to go work in the aerospace industry. I'm going to just show you some numbers. This is for the entire College of Engineering for last year. We had about 13,000 people apply for 1,400 incoming freshmen. And we accepted about 4,000 of those, and we were over-enrolled. We're having this problem that we keep getting more students, which is great, but it's hard to maintain the quality and without the additional resources. Those students, the ones that enrolled at Cal Poly, had an average high school GPA of 4.03 and an average SAT score of 1309. So a very highly qualified set of students. The students this year, I couldn't get the data together in time for the presentation because we haven't done, hasn't come out yet, but it's going to be higher. It just keeps getting higher and higher in terms of the quality of the incoming student. But I'm going to touch on something else there, though. At Cal Poly, what we're committed to is these membership, these interactions and these partnerships with industry to help inform our curriculum and to make sure that we're doing what you guys need in industry to develop the best workforce. We're also interested in actually placing our students in jobs. Right? That's one of our goals, is actually to get our students employed when they graduate. And then the faculty are always involved in kind of this applied research of how do you use these systems to do something. From an industry point of view, our students, 85% were employed within 6 months of graduation. Over half were employed, had job offers before they graduated, and this is just for the aerospace department, not for the entire college. They go to every company you can imagine within the aerospace industry, and then some outside the aerospace industry. Every once in a while, I had a student who joined a Formula One racing team. It happens. Okay. 71% of those students last year that were surveyed, they stayed in California. All right, so a majority of our students come from California, and a majority stay in California. So we're definitely providing the next level of the workforce. The challenge, though, that we face is the STEM pipeline that's been talked about before in terms of diversity and in terms of women and underrepresented minorities. I got this from the Level Playing Field Institute. It talks about these achievement gaps, all right, that are very well documented that tend to happen in 4th and 8th grade, where women and minorities tend to lose interest in STEM fields. And this is just some data that talks about their proficiency in math exams compared to white and Asian students. So you talk about what we can do as a state from a publicly funded educational system. We've got to deal with this problem. There's a demographer at USC who I heard talk a while ago that talked about, for the first time in modern California history, a majority of the people that live here were born here. Okay, so you think about what that means for our immigrant population and how things are changing from a demographics point of view. Folks that were born in a state tend to have more of an affinity for that state. So we have a diverse population. It's a plurality. There's no racial majority in the state, but the majority of the people that live here were born here. So we can develop that pipeline in a more quality way if we kind of think about it from that point of view. This is reflected. This is the data for our department at Cal Poly in the Aerospace and Engineering department in terms of what our student population looks like. We have about 400 students right now. 19% are underrepresented minorities, and about 15% are women. And that's we're pretty typical. All right, we're looking at ways to try to do more. As a college, we're actually up to 20% women, which is kind of a barrier that people look at as a good barrier to reach and to get past. Within aerospace, we have some challenges that we're working on. Within the workforce, this comes again from the Aviation Week workforce study, and I realize it's a lot of numbers out there, but if you look at underrepresented minorities, which is the column on the left, and then women, which is everything on your right-hand side, we're still in the single digits to 20-25% when it comes to women and underrepresented minorities. So this is a long pipeline, right? And the investments need to happen early from a public education K through 12 perspective. They need to happen as those students move into the universities and higher educational, community colleges and the universities. And then that investment needs to continue by the industry. And we heard a lot about that, which is really nice to hear, actually, about how these companies are taking seriously that they need to develop the diversity and inclusivity in their workforce. But we're kind of at the middle of all of that. So just as a department, what we like to say is learn by doing, practice and innovating aerospace. We do a lot. We focus on design. And so just throw up our vision and our mission is really focused on developing those students that can be a productive part of the workforce. Our initiatives really center around CubeSat and applications of autonomous flight. And we have the student in mind. So this is contraband. If I showed this logo to our president, I'd probably get drummed off because it's not official. But that there represents our student, where we like to think about learning and innovating and doing. So I think we're out of time for questions, but I thought I'd throw the slide up there anyway. Thank you.
Well, that actually went fast, and that was a huge amount of information, and I would like to invite everybody to the reception where you can ask questions one-on-one with the speakers, but let me sum up a little bit with some takeaway thoughts as we go into our reception and relax a little bit. I think what you saw today was a huge, amazing breadth of activities that are going on in aerospace in California. I think what you also saw as well is a huge depth of how those activities reach down from the very large primes into the communities at the supplier level, with fingers out to small suppliers, at the smaller mom and pop sort of places where the innovation's going on that the large companies are looking for. I think you saw that the breadth of the people who spoke here today really value the innovative culture of California and how that plays into the aerospace activities that go here. You also, I think, saw their passion for reaching out into the community and bringing along the next generation of STEM workers and getting students excited about science and math and engineering. And I don't think any one of us could argue about the fact that that is with the things that we do in our industry, which we're like the coolest industry around, I'm sorry, it's just the fact. We do things that attract students into the science and engineering world, and I have not met one person in my career in aerospace who has not been just really focused on trying to inspire the next generation to follow using this cool stuff we do as a lever. I think you also get the sense that there's a critical mass of things that are happening here in California across what the university systems are doing and how they're inspiring the students, how industry is here encouraging and acting as a magnet for people to educate themselves in the science and engineering fields and the technical skilled worlds, and how the industry and the innovation and the academia are working together. And I think it just it inspires us in the policy world as well to figure out how can we continue fostering this critical mass and this spirit that lives here in California. What kind of policies can we do? There's, I think, a wealth of resources in this room and in our community at AIAA to call upon to help figure out what is that right level of regulation versus standards versus how we foster this innovative spirit. So think about these things as we go to the reception, and please engage with our speakers. They're here to share their passion and their experiences working in California and in aerospace. And really, when you get one of us talking, it's going to be hard to shut us up because we're just so excited about what we do. So